Well, continuing on in our exponential unit, we're going to dive into another part of it called solving exponential equations. Now, there are two methods to solve this, and tonight we're just going to focus on method one, called common bases. So let's make sure we title this accurately. This is method one of solving exponential equations, called common bases. You're also going to want that calculator pretty handy, so once you pause it, go find it, and get ready to get going here. All right, so we need to slow down, pause, and get these guidelines clearly written in our notebook. All right, so again, these are the guidelines on solving exponential equations, method one, common base. So again, pause it and we'll read through them. Create a common base by rewriting each side as a base to a power. 2. Once you have common bases, clear the bases and set the exponents equal. And 3. Solve for all values and check. Okay, so again, pause it, make sure they're in there nice and neat, and we'll go through a bunch of examples. Exercise 1. Solve each of the following simple exponential equations. Now, I just want to remind you why they're called exponential. All right, and that's what we focused on yesterday. Exponential means the exponent has a variable. So as I look at exercise 1, I see 2 raised to the x power. The exponent is a variable, that's why it's called exponential. All right, so looking at the guidelines. Step 1 said rewrite each side as common bases. Well, as for now, I'm going to leave this as 2 to the x. And my goal is to rewrite 16 with a common base of 2. All right, so 16 is equivalent as to 2 to the what power? And that's what my goal is. I'm saying 16 equals 2 to the what power? Well, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, but 2 to the fourth, which is 2 times 2 times 2 times 2, is 16. So I'm going to rewrite 16 is 2 to the fourth. So I can cross off 16, and in place of it, put 2 to the fourth. Guideline 2 says once you have common bases, clear the bases and set the exponents equal. So I am saying x equals 4. Step 3 is to solve, but because this one's simple, it's typically solved for you. And now check. Is 2 to the fourth equal to 16? Check, that's true. And our answer is x equals 4. All right, if I went too fast, let's try another simple exponential equation. B. Again, this one's exponential because the exponent is a variable. So I'm going to leave this side as 3 to the x. And I'm saying 27 is equivalent to 3 to the what power? And just go through them. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. So I can replace 27 with 3 cubed because they're equivalent to each other. Again, once I have common bases, ignore the bases and set the exponents equal. X equals 3, and we'll quickly check. Is 3 to the third 27? So my solution is 3. Okay, and again, these are simple ones. All right, let's try the next one. I have 5 to the x equals, I have to get rid of 1 over 25. So my question is 5 to the what power equals 1 over 25. All right, now don't let these fractions scare you. All right, we're good at this, guys. We have a fraction if our exponent is what? That's all you're saying to yourself. I have a fraction because my exponent is, yes, negative. All right, so that's all it means. Ignore the fraction part. How do I go from 5 to 25? 5 to the what power? 5 squared. But because it's a fraction, it's going to be raised to the negative 2. So I'm going to say this is 5 to the negative 2. Remember, if you see a fraction, our exponent is negative. I clear the bases, and I'm going to say x equals negative 2. And we'll quickly check. 5 to the negative 2. That just puts it on the bottom. 1 over 5 squared is 1 over 25. All right, last one. Again, they're called simple for a reason. I'm going to say I have, now, 4 to the first is equal to 16 to what power? Well, I'm going to say this is really 4 squared. Okay, now I have to keep my exponent there. All right, so maybe I went too fast on that one for you. Let me slow down. You can actually manipulate either side, okay? And I always want to go with the smaller base. So I'm going to say 4 to the first is 4, and 4 squared is 16. So I rewrote this side, okay, which we have to do quite a bit. I'm going to rewrite this side. So 4 squared is 16. All right, so I'm just replacing 16. It's like me killing the 16 and putting a 4 squared there, and I have to keep the x. Now I'm going to clear the bases, and I'm going to say 2x equals 1, so x equals 1/2. All right, and we'll do a quick check. 16 to the 1/2, does that equal 4? Well, remember, that's really the square root of 16, which 4 equals 4, so my 1/2 checks. All right, we've got some basic ones out of the way. Let's move on here to exercise 2. It says simplify each of the following exponential equations. Okay, now again, I just want to say it one more time. They're exponential because the variable is in the exponent. And let's talk about this. I have power to a power in part A. Power to a power says keep the base and multiply the exponent. So I'm going to say that's really 2 to the 3x. That's all we're working on. Power to a power is multiply the exponents. Letter B, I'm going to keep the base at 3. Power to a power, multiply those exponents. I get 3 to the 8x. All right, C, keep the base. Power to a power is multiply. Now be smart here. Make sure you multiply that whole thing by -1. I'm going to say that's -3x, don't fall for that bear trap, plus 7. Make sure you multiply the whole exponent. Same idea in D here. I'm going to keep my base of 4. Power to a power. You've probably done it before I have here. Just multiply, so I get -3 plus 3x squared. All right, so we're going to start to use this technique in our next example. Exercise 3, solve each of the following exponential equations here by finding a common base for each side. All right, now I want you to start this in your notebook here. Here's what we want. We want to make the base as small as possible. And many times you're going to have to manipulate both sides. Okay, so let's look at example A. I can't just leave this as 8 because is 8 to any power 32? Well, 8 squared is 64, so it's not possible. I'm going to have to change both sides. So in my head, I'm saying make the base as small as possible. I start with the number 2 in my head. And I'm going to say, what is 8 equivalent to? 8 is equivalent as 2 to the what power? Okay, and if you can do it in your head, you don't have to write all this out, but I'm going to show you what I'm thinking. I know 2 cubed is 8. So I'm going to replace this 8 here with a 2 cubed. Okay, and I want you to wrap it in parentheses because we substituted, and it has an exponent of x equals. All right, now I have to do the same thing with a 32, and I need a common base, so I know I need my base to be 2. 2 to the what power is 32? Okay, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. So I'm going to replace 32 with 2 to the 5th. Okay, now I have my common bases. I'm going to go one more step here. I'm going to say this is really 2 to the what power? Power to a power says multiplies. That's 2 to the 3x equals 2 to the 5th. Okay, we've got our common bases so we can clear them, and we're setting the exponents equal. 3x equals 5, therefore x equals 5/3. All right, and we can do a quick check. We're going to say, plug that back in, 8 raised to the 5/3, does that equal 32? Well, remember, you're supposed to be able to do this in your head. This is really the cubed root of 8 to the 5th if I rewrite it as a radical. All right, now you can do whatever you think is easier. Do you think the cubed root of 8 is easier, or do you think the 5th root of 8 is easier? I think the cubed root is. The cubed root of 8 is 2, and 2 to the 5th is 32. So no calculator for this. We're going to slow down and really work on some of our old material. Let's try the next one. Okay. And if you got a little overwhelmed, just relax. We're going to go through these step by step. And remember, we're just trying to get a common base. So when I see those 9s there, what base pops in your head? I'm hoping it's the number 3. I'm going to say 9 is equivalent to 3 squared. Would you agree with that? And 27 is the same thing as 3 to the 3rd. Okay, so now I'm going to rewrite them. I'm going to basically replace this 9 with parentheses 3 squared, keep my exponent of 2x plus 1. I'm going to replace this 27 with just 3 cubed. If you can do that, you did the hard part. All right, now I'm going to clean this up by saying power to a power is multiply. So I'm going to say that's 3 to the, if I multiply those, that's 4x plus 2 equals 3 cubed. Nothing to multiply there. Now I have my common bases, so I can clear those, and I'm going to set the exponents equal. 4x plus 2 equals 3. 4x equals, if I subtract a 3, is 1. X equals 1/4. All right, let's do a quick check. 9 to the 2 times 1/4 plus 1 equals 27. And this gets me 9 to the, 2 times a fourth is 2/4 or 1/2 plus 1. And that's 9 to the 3/2 equals 27. All right, let's rewrite it. That's the square root of 9 cubed. The square root of 9 is 3, and 3 cubed is 27, so we know it checks. So our answer is x equals 1/4. And again, you could grab a calculator at that point. I'm just checking in my head. All right, part C. This is typically as ugly as they get. So if you feel good about this, you're in great shape. I'm going to say, all right, when I see 125, the number 5 still pops in my head. I don't know about you, but that's what I think. When I see 25s, I think 5. All right, so I'm going to start with 125 is equivalent to 5 to the what power? Let's see, 5 to the first is 5. 5 squared is 25. And 5 cubed is 125. So I'm going to say 125 is equivalent to 5 cubed. Now how about 1 over 25? All right, I know it looks scary, but remember, when you see a fraction, just remember that means your exponent was negative. So 5 to the negative what power gets me 25? Well, I see the 25 tells me 5 squared, so I'm going to say that's 5 to the negative 2. All right, so now I just replace them. I'm going to replace the 125 with 5 cubed, substitute it, and leave that x up there. I'm going to replace the 125 with 5 to the negative 2, substitute it with parentheses, and keep it to the 4 minus x. All right, so I just basically replace that and replace that. All right, now let's do our power to a power rule. This is really 5 to the 3x equals 5. Let's just be careful with this negative 2. Distribute it to the negative 8, plus 2x. All right, I've got bases the same, so I'm going to clear them and just set the exponents equal. So 3x equals negative 8 plus 2x. Subtract my 2x, I get x equals negative 8. Okay, and then a quick check, just like we did before. 125 to the negative 8 equals 1 over 25 to the, 4 minus negative 8? Well, at this point, I'm going to grab my calculator and type those in to see if they make sense. That's not one I can do off the top of my head very easily. So I'll show you. I just typed them in the calculator. I said 125 to the negative 8, and I got some hideous number. But that's okay, because when I typed this side in, I got the same hideous number. So I do know that they're equal, and it worked. Exercise 4. Which of the following represents the solution to this exponential equation? All right, so let's go to, we're going to work it out. I know you can guess and check with your calculator, but let's practice working them out. All right, I got to get a common base. So I'm going to say 2 is pretty small. I'm probably going to leave it at 2, and I'm going to work on this 64. All right, so I'm really saying in my head, 2 to what power equals 64? All right, 2 to the what power? And you just go through them until you get your answer. I'm going to say 2, I know 2 to the 5th is 32, so 2 to the 6th is 64. So I'm going to basically replace 64 with 2 to the 6th. Okay, so now my goal is to, a minus sign? I apologize. I've got common bases, so I'm setting my exponents equal. X squared minus 3 equals 6. So I get x squared equals 9. Now don't fall for that bear trap. We do it on our fun quiz or our bite-sized quiz every week. When you take that square root, how many answers should you be getting? I get x equals plus and minus 3. Okay, plus and minus 3. So when I go back and look at my choices, hopefully you'll see that in there, plus and minus 3, and it should check out. All right, we're building here. Exercise 5 says find all the solutions to the following equations. Check your solutions using the table on your graphing calculator. All right, so I see my favorite two numbers, 25 and 125. So hopefully, what number for a common basis popped in your head? All right, I'm hoping you said 20 or 5 at home. I can't hear you, but I'm hoping that's what you said. So I'm saying 5 to the what power is equal to 25, and 5 to the what power is equal to 125. That's my goal. All right, so why don't you pause it, rewrite your common base, and see if we get the same thing. I went with 5 squared for 25 and 5 cubed for 125. Okay, I substituted them in with parentheses because that's really all I'm doing. And now watch your power to a power. Remember, that means to multiply. So I keep my base, and I'm going to say that's to the 2x squared minus 10x. Keep my base on this side. Power to a power is multiply, so 3x minus 6. All right, common bases. We're going to get rid of those. We're going to set the exponents equal. All right, so again, why don't you pause it, see what you get, solve for x, and we'll see if we get the same thing. But try it on your own. Don't cheat yourself here. Well, I went through my work. I've got my problem set equal. I've set it equal to 0, factored, solved. I've got 1/2 and 6. So now remember, I have to store it back into the original question when I check these. And I'm going to go ahead and grab my calculator and check. And I want to show you how I checked, and I think this will be helpful. We've talked about it earlier in the year. We probably haven't done it in a while. But I basically said 6 store into x. So let's write that down on paper. 6 store, it says STO, it's near the on button, and then I hit X. 6 store into X and hit enter, and the 6 appears on my screen. And then I just typed the original one in, and I got that number, and I typed the other side in, and I got that number. And since they're equal, 6 checks. And I did the same thing for 1/2. I said 1/2 store into X. I typed the left side in and the right side in, and notice I got 2 huge, ugly numbers, but I went with it, or small numbers, I should say. And I just went with it. They match up, they're the same, so I know it checks. Just if you got that old calculator, watch your parentheses around your exponent. All right, now with these exponential equations, they like to throw some of the old school material we've talked about early on, back in September. So let's start with this exponential equation. 2 to the absolute value of x plus 3 equals 32 to the x. All right, so I'm going to attack it the same way. I need to get those common bases. So I'm going to keep it as 2 to the absolute value of x plus 3. And I'm going to mess around with 32. 32, I'm saying, is equivalent to 2 to the what power? All right, and maybe you have that memorized by now, hopefully. That is 2 to the 5th is 32. So I'm going to replace my 32 with 2 to the 5th, substitute it in, and leave it to the exponent of x. All right, now I'm going to go one step farther, of course, and I'm going to do my power to a power rule and say this is really 2 to the 5x. All right, so now I clear those equations, and now we have to remember how to solve absolute value equations. So like I said, it's been a while, but they're going to start to mix in all this old stuff. So remember, let's kind of walk through an absolute value equation. You'll start to see this more and more. My absolute value needs to be isolated. That's step number 1, and it is. And then I automatically split into 2 sections. I would say x plus 3 equals 5x, where I leave it alone. Okay, and then the x plus 3, don't touch the absolute value. It's just this one side you're making negative. Okay, solve each side. So I get, let's see, 3 equals 4x. 3 over 4 equals x. On this side, let's see, 3 equals minus x is negative 6x. Negative 3 over 6 equals x, or negative 1/2 equals x. All right, now especially with these absolute value, you have to check. I can't stress enough. So I'm going to check with the store button. I'm going to say 3/4 store into x, and I'm going to type that in my calculator. So look carefully at my checks here. I've got them typed in. I stored each number in. I said 3/4 store into x. Make sure you're practicing with your own calculator. And then I type these in. If you forget that absolute value, I believe, is math, and the first thing in there, maybe math number. And the first thing in there is the ABS for absolute value, if you forgot that. But you'll notice this one did not check. So we actually have to reject the negative 1/2. That does not work. And my only solution should be 3/4. So make sure you actually slow down and check these answers. There are times, especially in the absolute value and radical equations, where we reject answers. Well, we've made it to our last crazy example tonight. And again, we're going to throw some old school work in there. We've got a radical in this exponent. 36 to the square root of x equals 216. All right, so these numbers, the number 6 pops in my head right away when I see 36, so I'm hoping 6 is a power of 216. So off to the side, I'm saying 36 is really 6 squared, and 216, if you don't know it off the top of your head, just grab your calculator and, start raising things to powers till it works out. And I just tried my calculator, said, okay, let me try 3. And 6 cubed is 216, so that works. So again, I'm going to carefully replace 36 with 6 squared using parentheses. And I'm going to leave that radical x equals, I'm going to replace 216 with 6 cubed. All right, let's take care of our power to a power rule. I'm going to say this is really 6 to the 2 radical x. Notice I can't multiply insides and outsides together. All right, the 2's outside, the x is inside. They do not go together. And now I'm going to solve that equation. I've got those common bases, so I can clear those. And I'm going to say 2 radical x equals 3. All right, now again, let's talk through the rules. Before you go around squaring things, remember the order of operations. Like absolute value, you have to isolate that first. You have to isolate your radical first. So I'm going to say the square root of x equals 3 divided by 2. Now I can square both sides. Okay, and don't grab your calculator. Squaring a fraction is very easy. Those cancel. And you literally square the top and the bottom. So on top I get 9, and the bottom 4. No calculator needed. X equals 9/4. Now I do need to quickly check, so let's grab that calculator, store it in, and see what happens. And you can see on my screen there I stored my 9/4 into x. I got some lovely decimal, typed in my 36 to the radical x, and got 216. So 216 equals 216, and this equation checks. Well, we're going to get a lot of practice tomorrow, and if you felt overwhelmed at all, just come see us for help in the morning, and we'll be there. Have a great night. We'll see you then.